Hello and welcome to Diksha Karnataka YouTube channel. So in the topic under 30 minutes today, I am going to discuss another very important topic, which is the Lorentz force. So the Lorentz force and the motion of a charge in a magnetic field. So let us deep dive into it very soon. But before I start, just a request: if you are watching our channel for the first time, don't forget to subscribe to our channel by clicking in the description. And also, if you think that okay, we are helping, this video is helping you, do not forget to give it a like. That gives us the inspiration to make more such videos. So let's continue with our session for the day. So first of all, let us look into the learning objectives. We will basically know what is Lorentz force. We will find the direction using right hand rules. Also, we will derive the circular motion of a charged particle in a magnetic field, right? And apply the physics, explain the different paths, what will happen to the paths based on the angle between magnetic field and velocity. So let's start. So first is when you have say a charged particle in an electric field, what happens? Charged particle in an external electric field, it experiences a force, right? So external electric field was there, you kept a charged particle, so you have a charged particle Q and some electric field was there, so it will experience as a force. Now based on the charge is positive or negative, it can experience a force in the direction of the field, or it can experience a force in the opposite direction of the field. But anyway, so what is the force? The force was given by Q into E. We have done it in our electrostatics chapter. So whenever there is a charge in an electric field, it will experience a force, right? That is given by Q into E. So that is electric force. Okay, acts on the any charge, rest or moving. So even if the charge is at rest, even if the charge is moving, electric force will always be there. Sometimes we call it electrostatic force, so because on the static charge, but in general, even if the charge is moving, the electric force will still act on it. Okay, now parallel or anti-parallel to the electric field E. Parallel means if the electric charge is positive, it will be in the same direction of electric field. Anti-parallel means if the electric field charge is negative, the force acting on the charge is in the opposite direction. That's it. Okay, now can do work changes the speed. So if you are doing some work, its speed changes, right? Now next is magnetic force. This is a new force that we are going to learn. Now here one important point that is not very clear from here. So the force is a vector quantity. So let us add the vector sign here. They are using a bold symbol, so vector sign may not be clearly visible. Now when you are talking about magnetic field, when a charged particle moves in a magnetic field, it also experiences a force. Now here that force is given by Q into V cross B. Okay, V is velocity vector, V is velocity vector, B is magnetic field. So here this force acts only on a moving charge. This force acts only on moving charge. If the charge is stationary, no matter how big is the magnetic field is, it will not experience any force. Okay, perpendicular to both V and B. Here this force is perpendicular not only to V but also B. It is mutually perpendicular to V and B. I will share how to find the direction, don't worry. Okay, never does work, speed stays constant. So this force is a no work force. Okay, this is a no work force. Okay, so it does not do any extra work. So something new we have learned. So far we have no idea what is this force is. This force is a no work force. It does not do any work on the charge. Okay, speed remains same. Speed means direction can change, but the magnitude of the speed remains same. Now let's move on with next part. So the Lorentz force. So what is Lorentz force? Lorentz force is basically when you take the electric component of force and magnetic component of force, and if you add them together and give it a name, then that is called Lorentz force. Okay, Lorentz force is basically, this is the electric force component of the force, This is the magnetic component of the force. You just add them using a plus sign. That is called Lorentz force. Okay, here Q is charge, Coulomb sign matters, it flips the force direction. So if the charge is positive and the force, say net force, say in x direction, okay, obviously you have to add them. If the charge is negative, the net force will be in the negative x direction. So whatever the sign of the charge, based on that the direction can change, but generally whatever direction that we will tell you, that is valid for positive charge. If the charge is negative, then you just need to change its direction according to it, right? E is electric field, volt per meter, pushes every even a stationary charge. Okay, V cross B is the magnetic term. Okay, Tesla field, cross product is force. Force is perpendicular to both V and B. This is the total electromagnetic force on a point charge, named after Henrik Lorentz. So Henrik Lorentz is the person who was somewhat wrote in his paper, like he used to write paper, right? Not exam paper. So scientists, physicists, they write papers on theory. Okay, he said that when a charged particle is moving in electric and magnetic field, what happens to it? That was his topic, and he showed that you can actually add them simply like this, vector addition, and the net force can be calculated using this. So that was his topic of his paper, and based on that it is called Lorentz force. Okay, now how strong the magnetic force? Now we are only discussing about magnetic force. We will not discuss about Q into E. We have done a lot of discussion of Q into E in electrostatics chapter, obviously. So we are more inclined to something new that we have learned in this chapter, which is the magnetic force. So magnetic force is given by Q into V cross B. Now if you just take the magnitude, it becomes VB sine theta. Cross product can be replaced by a sine theta when you are using scalar form. Okay, now this VB is measured in Tesla. Okay, this B is measured in Tesla. 1 Tesla equals to 1 Newton second per Coulomb meter. 1 Tesla equals to 1 Newton second per Coulomb meter. Okay, now if the theta is equals to 0 or 180 degrees, force becomes 0. So if this theta is 0 or 180 degrees, then this force becomes 0. Okay, no force at all. If the theta is 90 degrees, then this force becomes QVB. If this theta becomes 90 degrees, this becomes QVB. V perpendicular to B, maximum force. So if V and B are perpendicular to each other, okay, then the force becomes maximum. Okay, and if the particle is at rest, then the force is 0. So basically we are discussing the entire summary of this portion. So if you are someone who is struggling with Lorentz force, MCQs of Lorentz force, this is a must watch for you. Do not skip, do not pause it right now and think, sir, what are you discussing? It is the same thing that we have hearing again and again. This is a summary of the entire part. Right now, right hand rule. So that's how you find the direction of the magnetic force. Point your fingers in the direction of velocity. Suppose this is the velocity, this is the magnetic field. Now for most cases we choose the case where V and B are perpendicular. Okay, that is the most common case. If that is not going to happen, we will see the last part of this lecture what will happen to the motion. For now we are assuming that V and B are perpendicular, so QVB sine theta becomes only QVB, right? Sine 90 is 1. Now magnetic field, so I discussed it multiple times. What is the meaning of dot and cross? Let us explain me once more. So cross means into the page. Cross sign means into the page. This is a 3-dimensional thing. We cannot always draw 3-dimensional thing in 2D image. So cross means into the page, and dot refers to out of the page. Okay. Cross means into the page, target, practice. Out of the page, like someone is shooting from here, so it is coming out, so out of the page. Okay, now here magnetic field is denoted by cross. So magnetic field is denoted by cross means magnetic field is into the page. Okay, now velocity is in this direction. How do we find the direction of force? First, take your right hand, point your fingers in the direction of the velocity. Okay, next curl them towards magnetic field B. So curl them towards magnetic field B. Only this finger, these four fingers. Okay, so first point them towards velocity V, then curl them towards the magnetic field. Magnetic field is into the paper here. Magnetic field is into the paper. Into the paper means I will curl it towards the paper, right? I will curl it towards the paper. So if you curl it, then your thumb points along F for positive charge. Then your thumb points the force for a positive charge. If the charge is negative, you do the same thing. Thumb points up. That means the force will be on the opposite side. You don't need to remember anything else for negative charge. Only thing that you need to remember is that if you are using a negative charge, after finding for the positive, the direction will be opposite. Okay, negative charge, the force flips to the opposite side. Okay, so if you are doing it for the positive charge, negative will be exactly opposite, right? So thumbs up, thumbs down. Next is magnetic force does no work. So as I mentioned, magnetic force is the no work force. It does not do any work. Main reason is that it is always perpendicular to velocity. Force is always perpendicular to velocity at each and every instant. So force F into V is 0. The power delivered is 0. So if you remember in your first PUC, you calculated that power delivered was given by force into velocity. So here force and velocity are perpendicular. So FB cos theta is 0, and that means power delivered is 0. So if power delivered is 0, then basically it refers to no work force. Also you can say that if velocity is this direction, means the motion is in this direction, force is in opposite in the perpendicular direction. So motion and force, they are 90 degrees, right? So that is example of no work force. Remember the example when a coolie was lifting something on his head. He is moving in this direction, gravitational force acting downward, the direction and the force are perpendicular. So that was an example of no work force as well. Earth rotating around sun, moon rotating around earth, they are all no work forces. Okay, speed never changes. If V and B are perpendicular to each other, speed remains constant, kinetic energy stays constant, delta V is same throughout the motion. So no matter what happens, magnetic force cannot change its speed. Electric force can change its speed. Electric force can accelerate the particle, but magnetic force cannot do that. Magnetic force cannot force a particle to change its speed. Magnetic force only can bind a particle, or it can say that, okay, you are bound to me, you have to rotate around me. That's what magnetic force can do, but it cannot accelerate. It cannot not accelerate. You will say the speed will not change. The magnitude of velocity will not change. The velocity direction will change, but magnitude wise velocity will not change. Okay, only direction changes. The force steers the charge, it bends the path without speeding it up. So it is basically something which just says, okay, you can change your direction, but you cannot change your value. Okay, so work done is 0, change in kinetic energy is 0, speed is constant, path merely curves. Path merely curves means the direction only changes. Okay, so these are the very important point about this. Now let us find the radius. Okay, so what will happen if the particle is suppose moving in this direction, magnetic field is into the page of the paper, okay, then the particle will experience a force in a particular direction, and what will happen, this will force the particle to move in a circular path. Okay, the force will force the particle to move in a circular path. Okay, and this force will act as centripetal force. This force will act as centrifugal force. The force is always perpendicular to V. It points at one fixed center, that is exactly a centripetal force. So the magnetic force must provide the required centripetal force. So QVB must be equals to mv square by r. From here you can calculate r is equal to mv upon qb. Okay, now mv can be replaced by momentum p. Sometimes it might be asked that two particles are entering a magnetic field with same momentum, same kinetic energy, like that. So in that case, this formula comes handy. This formula comes handy. Okay, faster or heavier particles, bigger circles, stronger fields, tighter circles. So if the field is stronger, the circle is smaller. If the particle is heavier, it will rotate in a longer circle. It will take long time to rotate. Okay, if the particle is fast also, they will also take, I can rotate very long distance, I can run very long distance, so that will also rotate in a longer distance. Okay, now time for full circle. Time for full circle is 2 pi r by v, okay, which is given by 2 pi m by qb, and frequency of rotation is given by f is equal to qb by 2 pi m. Okay, another formula is omega. Omega is 2 pi f, okay, or it will be omega equals to qb by m. Okay, this is the angular frequency. This is called angular frequency. This is angular frequency. Okay, this is normal frequency of revolution is qb by 2 pi m. Time period is 2 pi m by qb. Based on this, questions have been asked in the past, so make sure you prepare them. T and F do not depend on the speed or radius. So this is very important, that time period and frequency, they are independent of velocity. Okay, time period only depends on mass, the magnetic field and the charge. Okay, even frequency also, even the angular frequency also. So velocity does not change. If the particle's velocity is doubled, the time period will not change. Time period depends only on mass, charge and magnetic field. So that is a very important point for any MCQ question. Okay, fast particles run bigger laps, slow particles run smaller laps, all finish the same path. This is single fact makes the cyclotron possible. So this is an application of this process, which is cyclotron. Okay, now if the particle is moving with the angle, velocity, the sign, the theta is not zero, theta is not 90 degree. Theta is not 90 degree, then what will happen? The particle will continue its linear circular motion, but it will also continue with a linear motion. So what will happen, I will explain. So suppose this was the velocity which was not a suppose this is the velocity which is not 90 degrees. So you can find a component which is basically perpendicular to magnetic field and a component which is not perpendicular to the magnetic field. Okay, you will have two components. This diagram is slightly misleading because it is at some angle. So you will find one angle like this, one angle like this. Okay, so this is the two-dimensional angle. Okay, so this is the angle, this is the angle, this is the angle. Okay, so this is all, everything is on this plane, Okay, now this one will, the perpendicular component will, this is the magnetic field. Okay, magnetic field, say into the page of the paper. So this will be, there will be a centripetal force because of this component, and there will be another component which will take it in the forward direction. So particle will move like this. Okay, so this motion is called a helical motion. So the cos theta component, okay, along B feels no force, drifts forward and steady rate. Okay, so this is the component which is the taking it forward, which is V cos theta. Okay, this angle is say theta, and V sin theta across B, it turns in a circle of radius r is equal to mv by qb. Okay, pitch is given by V parallel by t. Okay, so forward distance per turn, which is called pitch, which is 2 pi m q V by cos theta by qb. Okay, so this is called pitch. Now where this physics show up, so one is cyclotron, Okay, the syllabus is not there, but we should learn basics about it. Okay, because it's F is independent of speed. One fixed frequency voltage can keep accelerating protons lap after lap to very high energy. So basically it's a device which produces high energy particles. Cyclotron is one of them. Okay, velocity selectors, multiple particles are coming with different velocities. You want only one velocity to stay there, remaining velocities to go out. So that can be done using this technology. Next is auroras. Aurora borealis and aurora australis, both are solar wind charged spiral helical along Earth's magnetic field lines toward the poles, lighting up the sky as they hit the atmosphere. So aurora borealis, one of the beauties of nature that is possible because of this motion of charged particle in magnetic field. So here the magnetic field is Earth, and the charged particle gets trapped around the poles only, and those particles interact with Earth's atmosphere and creates beautiful light, northern light, southern light. There are two lights. Okay, that can be observed. Southern light you cannot observe, northern light can only be observed. Southern light you have to go to a restricted place, which is maybe you can go there, but not super legal. You have to take a lot of permissions for a lot of people. So that's why southern light is not that popular, but northern lights are. Okay, also mass spectrometers, TV tubes, old TV tubes, old generation TV tubes, Hall effect sensors, tokamak, plasma confinement. Okay, these are very high level experiments. Okay, Hall effect, maybe if you study physics in future you might study what is a Hall effect. We have to do an experiment. Hall effect is one of the difficult experiment because it requires a lot of accuracy to get the correct result. Okay, so that one experiment is based on this technology. Okay, TV tubes, obviously old generation cathode ray TV tubes actually had a similar technology. Okay, now let's see a few things. Workout example: an electron mass is given, charge is given, enters a magnetic field B 0.1 Tesla at V is equal to 2.0 into 10 to the power of 6 meter per second, perpendicular to B. Find the radius of the path. So obviously radius is given by r mv by qb. Okay, put the values and simplify. You will get the answer to be 0.11 millimeter. Okay, 0.11 millimeter, which is a tiny tight circle. Okay, next is summary. So Lorentz force is given by F is equal to Q into E cross V, E into V cross B. Magnitude F is equal to Q VB sine theta. Radius r mv by qb. Period is t is equal to 2 pi m by qb. Okay, next cyclotron frequency. This is the frequency or cyclotron frequency, sometimes it is called. Helix pitch is 2 pi m v cos theta by qb. Okay, remember the magnetic force does no work, only it bends the path, right? So this is a short summary of this portion, and if you liked it, as I mentioned, don't forget to subscribe to our channel, and obviously if you feel that I am doing some good for you, then don't forget to like this video. I'll be back with more such short topics so that your basic understanding and basic curiosity is solved as much as possible. And if you have any questions, any doubts, don't forget to mention in the comment below. I will try to address them as soon as possible. Till then, bye.